For this video, we're going to review what we've done so far to get ready for our quiz that's in the next class. So to start with, we graphed exponential functions, right? Remember, we have that equation with A, H, and K, where A is going to tell us, if it's stretched or compressed or reflected. H is our horizontal translation, and it's always the opposite sign. K is our vertical, and it keeps the same sign. That's what's happened in all of our equations we've looked at so far. But for exponential, we consider AB to the x to be our parent function. So whatever AB to the x is what we make our table for. Then once we have those points, we translate them based on our horizontal and our vertical translation. Alright, the K is also another important part of our graph, and that's our asymptote. So that's the part of the graph that the curve will never cross. It's going to get infinitely close, but never actually touch that asymptote. So for our example, we have 2 times 1/3 to the x plus 1 minus 4. I'm going to make my table for everything to the left of that x. I'm going to ignore the h and the k for now. So my table is going to be for 2 times 1/3 to the x, and my table is the same table every time. -2, -1, 0, 1, and 2. Okay, so I'm going to start by plugging in. So we have 2 times 1/3 to the -2. Alright, but I can't have a negative exponent. Right, so this part, alright, to make it positive, I'm going to flip my fraction. So I end up with 2 times a 3 to the positive 2, which is 3 squared is 2. 2 times 9 is 18. So that becomes an 18. Now I can continue to plug in these points to 2 times 1/3 to the x, or this tells me that it's decaying by 1/3 every time. So once I have my original number, I can just divide by 3. So 18 divided by 3 is 6. 6 divided by 3 is 2. 2 divided by 3 is 2/3. And then to do it one more time, 2/3 times 1/3 is going to be 2/9. Okay, so you can either divide by 3 or multiply by 1/3 every time and to finish filling in your table. So now I'm going to take and plot these 5 points. So I have -2, 18, which 2, 4, 5, that's 10. So -2, 18 is going to be way up here somewhere. -1, 6. 0, 2, 1 and 2/3 is right about there. And then 2 and 2/9 is going to be smaller, so we'll estimate to be right there. So there's my parent function. But I'm not graphing my parent function, I'm graphing this function, and this plus 1 tells me that I'm going left 1, because it's really a -1. And this minus 4 tells me I'm going down 4. So I'm going to take all of my points and go left 1, down 4. And I'm also going to have an asymptote in there at -4. So if I wanted to, I could go ahead and draw in that dotted line at -4. And then take all of my points, and we're going to go left 1, down 4. Alright, about there. Left 1, down 4. Left 1, down 4. Left 1, down 4. And this one, we're going to go left 1, but it's still going to be up here somewhere, so we'll estimate there. And then I'm going to try to connect to get my exponential curve. Alright, my domain is always all real numbers. And my range is always going to be based on k. So in this case, I'm going up forever, so I'm going to use a positive infinity that always goes on the right-hand side. And then my k value is -4, and I put a parenthesis since it's an asymptote. Right, then we solved exponential equations, and we had 3 different ways of solving. First is our common base. Right, so we want to find a base that fits all of the terms, and then once we do that, we apply our exponent rules, and then we can solve. So remember, if you have a fraction, that immediately means you're going to have a negative exponent. Every single time a fraction is a negative exponent. So if I look at 2, 32, and 2, my common base is going to be 2. Nothing else goes into 2, so I've got 2 to the x. Alright, now 32 equals 2 to the 5th power, which means 1 over 32 equals 2 to the -5th power. And then 32 we said was 2 to the +5. Right, now I have to combine the left side over here, and I'm multiplying with the same base, so I add my exponents. So I have 2 to the x plus -5 is just x minus 5 equals 2 to the 5th. Now that my bases are the same, I don't need them. So x minus 5 equals 5, and to solve for x, I just add 5 to both sides. So x equals 10. Alright, over here, anytime we have a 1, 1 equals your base to the 0 power. So that it can be whatever base you want it to be. So in this case, I'm just going to leave it as 4. So I have 4 to the 2x plus 3 equals 4 to the 0 power. My bases are the same. Everything's simplified. So I have 2x plus 3 equals 0. Subtract the 3 from both sides. 2x equals negative 3. And divide by 2. So then we just leave it as an improper fraction. Negative 3 over 2. Right? Negative exponents when you have a fraction. A 0 is when you have 1. Every single time you have 1, you have something to the 0 power. Alright, then we use the calculator. Alright, remember in the calculator, you just cut it at the equal sign. Left side goes into y1, right side goes into y2. So let me pull my calculator up. So I'm going to go to y equals, and I have 3, and we're going to say to the x power. We always use an x in our calculator. And then in y2, 17. So I'm going to go to my graph. 17 is going to be up above my screen, so once I let it finish loading, I'm just going to zoom out. So zoom, 3, enter. And see if I can see that horizontal line. Which I can, so once I see it, I'm going to go second trace, number 5, enter, enter, enter. And my x value is my answer, so we get 2.58. So b equals 2.58. Okay, same thing for my other example. Left side in y1, right side in y2, but this time I have a little more to type in. No big deal. Go to y equals, let me clear out what's in there. So on this side I've got 16 caret, and I'm going to open a parentheses because I want this entire n minus 7, or x minus 7, to be in my exponent. Alright, close that parentheses, and then plus 5. So there's the left side. Right side, 24. Alright, I'm going to go back to, well, we'll just graph. Alright, so I'm going to have an exponential, and then I need a horizontal line. I can see all of it. I can see that intersection. So second trace 5, enter, enter, enter. And my x value is my answer, which we get 8.06. So n equals 8.06. So that's always an option. It's just left side in y1, right side in y2. Even when we do these examples, you can still do that in your calculator. Left side in y1, right side in y2. Every equation you can do that. Right, and then the third way we solved was using logarithms. Alright, so for this first example, I have a base to a power equals a number, so it's ready to go. So I'm just going to take a log of both sides. So I have a log of 6 to the n equals log of 99. Right, then my power property says I can put that exponent out front. So n times log of 6 equals log of 99. And remember, log of 6, that's a number value. Log of 99, that's a number value. So I have n times a number equals a number. So to get n by itself, I have to divide. Alright, so then in my calculator, I'm just going to type in log of 99 divided by log of 6. Now when I do this, let's get out of my graph. I'm going to type in, remember, logs next to the number 7. Log of 99, I have to close that parentheses. Because if not, it's going to take the 99 divided by log 6 and then take a log of that. So close that parentheses, divided by log of 6. And it's a good habit, go ahead and close the other parentheses. So we get 2.56. Alright, for the second example, I can't take a log yet because I need to get just this part by itself, the base to an exponent. So I'm going to subtract the 3, and we get 9 to the n plus 10 equals, and then 81 minus 3 is 78. Now I have everything where I have a base to an exponent equals a number, so I'm going to take a log of both sides. Alright, power rule says I can put that exponent out front, leave it in parentheses when it's more than just a letter. Alright, I'm going to start by getting rid of the log 9. It's multiplied right now, so I'm going to divide by log of 9. So I get n plus 10 equals, and I'm not going to plug it in just yet because I don't want to round too early. So I'm just going to leave that as log of 78 divided by log of 9. And then to get n by itself, I just need to subtract 10 from both sides. So now, this is what I can type into my calculator. So pull up my calculator. we've got log, of 78, close the parentheses, divided by log of 9. And I'm going to go ahead and press enter, get that number, and then just minus 10. So we get n equals negative 8.02. And the last thing we looked at were word problems. So remember, with our word problems, we have our formula, a equals p times 1 plus or minus r to the t. And that's our basic formula. Sometimes it changes if it's not annual, right? But this is an annual question. Remember, a is your final amount, p is your principal, your initial amount, and then r is your rate as a decimal, and t is your time. The plus or minus comes in with whether or not it's increasing or decreasing. So you buy a new car for $22,500. The value of the car decreases by 25% each year. So decreases tells me I'm going to be subtracting, and then 25% is going to be 0.25. I want to write an exponential decay model giving the car's value after t years, and I want to know the value after 3 years. So I'm just going to plug in first. So a equals, my principal is this 22,500. And then I have 1 minus my rate of 0.25 to the t. And I'm going to go ahead and simplify that. So we get 22,500 times 0.75 to the t. So here's my equation. Now I want to find the value of the car after 3 years. So I'm just going to plug in 3 for t. So I get 22,500 times 0.75 to the third. Go to my calculator, and we get 22,500 times 0.75 caret 3. So, after 3 years, it's $9,492.19. So we get 94.92.19. Alright, so you have to remember this basic equation. It might change a little if this was quarterly or biannually or something. The only thing that changes is we have to add that n in there. So we get 1 plus or minus, and then we divide by n and multiply by n. So that n's the only different part, so make sure you at least have this much memorized, and you can always add in the n.